Hello Chemistry, Mr. Singer here, and we are going to do a lab that we call a red cabbage indicator lab. You see, in chemistry, one of the frustrations is when something's going on in the container, it may be lots of things going on, but we can't see it. We don't know what's going on. How can we find out what's going on? And when it comes to acids and bases, sometimes you can taste it and you can know whether or not it's acidic or basic. Maybe some of you have tasted a little soap, but that's not always safe. As we talked about, you could take an acid and burn your tissues and so forth. So we need to have indicators, something to indicate something has happened. And so the first part of this lab gives us the instructions to take some red cabbage and boil it, and we're going to save the juice. So that's the process we're going to do right now. I'm going to take off some cabbage and just tear it up into little pieces. This is red cabbage that, yes, you would find in the grocery store. Hopefully some of you eat it. Part of this cabbage is gone because he's already turned into salad. I've been cooked some, so it doesn't take a whole lot, but we're going to make sure we have plenty. And we're going to boil this and use the juice from this cabbage as an indicator to tell us whether or not something's an acid or a base. So this is the time-lapse video, so what happened in over 10 minutes you can watch in just a matter of a few seconds. Here we have our cooked cabbage and the juice in it. We're going to put the juice into these test tubes, and we're going to use this as our indicator. So while he's pouring that in there, I just want to mention that growing up, my mom used to make cabbage soup, often called borscht, and I always wondered why each time it was cooked it was a little different color. And it's because she put different vegetables in there, and as you'll see, depending on how acidic or basic it was, that changed the color of how the cabbage stew looked.
So one of the common questions is, can I eat this? Well, the answer is yes, it's edible.
So we've made our cabbage juice and we've put it into our test tubes, and now we're going to use that as an indicator to try to tell whether something is an acid or a base and just how acidic or basic it is. So anything that's going to change color in the presence of an acid or a base is called an indicator. We're going to use 2 or 3 different indicators in this lab, and you should have a lab paper that looks like this, and at the top you have the numbers to the correlating colors that we're going to see to tell the pH of the acid or base. But before we do the cabbage indicator, we're going to do what's called a litmus paper. Litmus is often used in other contexts besides chemistry, but it comes from chemistry. And it is such that it's been made either blue, as they call it, or red. Now that's not a real bright red, but it's sort of a pinkish color. So this is called red litmus, and this is called blue litmus. Now, if it's in one thing, it'll turn blue, and the other one it'll turn red. So if I put it in something and it doesn't change, like this is water, it doesn't change, well, was it acidic or basic? I don't know. So that's why we have another one that we can put in there and see, well, does it change? So on the first indicator, which is on your lab paper, you're going to put here litmus paper. Is it an acid or base based on the color? So you're going to write the color. So the first one I like to try is hydrochloric acid. In its name, we already know what it is, so that's one good place to start. So in column 1, you're going to write chemical name is hydrochloric acid. The common name, you should remember from the last chapter, is muriatic acid. Muriatic acid. So the first thing we're going to do to each of these samples is we're going to see whether or not it's an acid or a base by doing a litmus test. Now, I'm going to take one of these red litmus and put it in there and see, well, that was kind of boring. It's still red. Well, let's see what happens if I put a blue one in there. As you can see, it has turned red, or sort of a pinkish color, salmon color. So this is the indicator of an acid. Now, there's also some other fancy paper called pH paper that is made up of many indicators, and so it has multiple colors, and so we can actually even take this. It comes in a roll, and you just tear off a piece, and then you can check and see what this says. And then we can hold that color up to here. We can say, oh, well, that looks like it's close to a 1 to a 3, somewhere there. Well, let's try the cabbage juice. So we're going to take some of this and put it into here and see what we get for color. You can see we get a beautiful, beautiful bright red. Now this is where you look at your lab paper and you'll see across the top 2, 4, 6, 8, 10, 12. That's the pH according to the color, and here's the colors written there. So I want you to write down what you think the pH is based on the color that you see here. Some of them are super easy, some of them are a little bit tricky. The next one we're going to do is lemon juice. So let me put this out of the way. And we're going to cut a lemon. And we're going to squeeze a little lemon right into the test tube. So, lemon juice is pretty pink. Now, not quite as bright as the hydrochloric acid, but pretty close. Oh, I forgot. I need to do a litmus paper. So, if it's an acidic one, we know that it'll probably keep the litmus paper sort of pink. So let's grab a blue one. And let's see what that does to a blue one. You can see it's turned it sort of a pinkish, reddish color there. Okay, so that was the lemon. That's what you should have in column 2 on your lab, lemon juice. It asks you for the chemical formula, and I'll let you look up citric acid. That's the chemical formula that you need to look up for lemon juice. Okay, number 3 is vinegar. Vinegar, we're going to put a little of that in here. And I'm going to, being a little bit lazy here by not putting everything in a beaker. So you can see that it turned the litmus paper a little bit of a pink. So, is vinegar an acid or a base? And you can see that it's definitely on the red category. So, all right, now I forgot to get started here, and we're going to put, I just wanted to show you, this is some Tums. I took it out of this roll, and we're going to add some water to this to let it start to dissolve. So we'll get that guy going. And similarly, some baking soda. There, I already put it in there, and we'll let that start to dissolve. All right, so that was going to be the next two that I do, but I forgot to get them dissolving in time, so we're going to skip those two, and we're going to go on to Drano, or Lye. Now Drano is a brand name, and it's just for chemicals that can clean the drains. And even this one here, you'll see that it's a drain opener or cleaner, and it is sulfuric acid. It's called a drain opener. This is sodium hydroxide. It is also called a drain opener. It's used for doing that. So I'm going to put a little of this into here. And let's take some of this litmus paper and see what it shows us. This is going to go in column number 6. Number 6. We took that pink paper and turned it blue. We could also take the blue and we could make it turn even more blue. So this is clearly a base, very strong base. Let's just for fun take some of this pH paper and tear it off and see what color it turns the pH paper. You can see the pH paper turns very, very dark, so it's past an 11 as far as pH is concerned. All right, so we're going to put this in column 6, or test tube number 6. 1, 2, 3, 4, 5, 6. And you can see what a beautiful green color that turned this cabbage juice. So if it's green, greenish yellow, what's the pH? Okay. Let's see how our baking soda is doing. It's dissolving. We'll give it another little moment here. The next one is kind of a fun one. This is borax. You can buy this at the grocery store, as you can many of these things. Many of us don't know what it is, but this is often used as a laundry booster. It's almost as widely usable as baking soda in many ways. It's different. It is naturally found in nature. It's mined here in California, near Death Valley. It's been used for thousands of years as a cleanser. It is actually good for even insecticide. It bonds to chemicals that don't let them live, which is one reason why you shouldn't eat it. It's not necessarily good for you. You can get toxic reactions from consuming it, but you can get that from eating soap or anything else that we often have around the house. So this is borax. Now, borax, I like to do it just because it makes a fun color. But to start with, let's look at the litmus test. You can see the litmus, it turns it a blue. Let's double check by taking a pink one here and see what color it turns it. It turns it blue. So according to our litmus test, it is a base. This is going to go in column number 7. 1, 2, 3, 4, 5, 6, 7. And it kind of breaks the rules for color. I always ask the girls to tell me what color that is. It's sort of it's got a little hint of purple to it and gray. I don't know what color it is. It's just kind of a fun one. So it doesn't fit our scale very well. But the pH of it is around 9.5. pH of all these things, it does matter what the concentration is. The more concentrated, the more the pH is going to be extreme in one direction or another. Okay, so that's the borax. And then we have bleach, household bleach. Household bleach. Let's try, first of all, putting in one of our strips. And you can see the strip, what color it's come back to number 5 here. And we're going to put baking soda in now that it's mostly dissolved. First of all, baking soda. What's the litmus paper show? And well, let's just for fun do the pH paper, and we'll put it in there. You can see what color it turns. So based on that color, all right, so we're going to add this baking soda to number 5. No, this is number 4. 1, 2, 3, 4. Baking soda. On the cabbage juice, it's kind of boring, but there's a hint of green. It's kind of a bluish, more blue than green. It is not a very strong base, but it is a base. According to our pH strip, we were probably between 8 and 9, so we're not too far from 7. This is one reason why you can put it in your food and so forth, and it won't hurt you. All right, the next one is going to be very similar to baking soda. It's antacids, and this particular one we're going to do, there are several. This antacid is calcium carbonate. And we've got some others here, magnesium hydroxide, and we're going to try putting in the calcium carbonate. It does not like to dissolve, okay? It's not very soluble, but this is going into number 1, 2, 3, 4, 5. Number 5, the antacid. This antacid is actually made out of powdered limestone, the same thing that the Washington Memorial is made out of and the Lincoln Memorial. All right, the antacid, beautiful blue color, not too different than what the cabbage juice was, so the pH is not very much different than water. Here we're just going to put the litmus paper in there, and you can see it's almost like it's water, just getting it kind of wet. Let's just try some blue and see if it changes that anymore. And it pretty much just looks like it's wet. It's not very strong one way or the other. It's just barely past 7 towards an 8. All right, on to the end. We're going to do this as test tube number 9, and we're going to put in here ammonia. Ammonia is NH3, and its common name and its chemical name are the same. So we'll put a little of that there. And let's put the litmus paper in there. You can see that that's sort of blue. Let's try a pink one, a red one. You can see what color it turns there. So let's put this in the test tube. So you get a really nice green color there for our ammonia. Okay, and last but not least, I didn't have enough to get 10 test tubes in here, but we have here sulfuric acid. This stuff is nasty, nasty, nasty stuff. Sulfuric acid. So take the blue litmus paper. What do you expect? It's that pinkish reddish color. And of course, if I do the pink, it is still very, very pink. All right. Now, what's going to happen when we add that to the test tube? Just want to remind you that sulfuric acid is also known as battery acid for car batteries. So you need to say what kind of a pH you think that sulfuric acid is. And that summarizes all of our different chemicals and their pHs. So once again, this is hydrochloric acid, lemon juice, vinegar, baking soda, antacid, Drano or lye. This was the borax. This is bleach, which I managed to bleach out because I put so much in there. And ammonia and sulfuric acid. One other thing is we don't mix these chemicals at one time because some of them can make some stuff that's dangerous. So don't ever mix chemicals that you don't know what they are and what you'll get from them, like cleansers and so forth. They'll put 2 cleansers down the same toilet because you can get different results than you do not want to have. All right, lastly, in this case, I get to clean up, and you need to write a conclusion for your lab. Don't forget to tell me what the chemical names and so forth are, write them in there, all right? That's all for now. Thank you. Here's a picture here that follows, so you can see all the colors clearly and up close.